Back in 2014, a Dutch firm called Switch Datacenters bought the AMS2 data centre in Verden, just south of Amsterdam, from the Dutch bank ABN AMRO. It's a big old unit with a footprint of more than 5,000 square metres, or almost 60,000 square feet. Up until that point, ABN AMRO had been using industrial air conditioning units to cool down their servers. AC units are extremely energy hungry, and as we've explored in previous videos, they're already, and will increasingly be, a major contributor to our growing greenhouse gas emissions crisis. While they were doing all that expensive carbon-heavy processor cooling, ABN AMRO were also running gas generator units to heat up all their offices and service buildings. Now, I don't know if you've spotted the slight flaw in that strategy, but if not, let me help you. You see, it's all to do with a concept known as complete insanity. ABN AMRO weren't unique, of course. The same madness has until fairly recently been pretty much standard in the vast majority of data centres, and for that matter the vast majority of industrial processing plants all over the planet. What would my hero of lateral thinking Edward de Bono have said to all those operators? Well, he'd have probably said the same thing you're likely shouting at the screen right now, which is, why not find a way of capturing all that process heat and doing something a bit more bloody useful with it? I agree, and so do the new owners of the AMS2 data centre, who have now implemented a system to do just that. And it's not just Switch data centres who have apparently experienced the epiphanically blinding light of the epically blindingly obvious. The EU has been running projects to find solutions to this major climate issue for several years, as has the US National Renewable Energy Laboratory and many other academic and commercial enterprises around the globe. So I guess the question is, how close are we to fixing the problem? Hello and welcome to Just Have a Think. Back in 2016, an energy industry consultant called Mark Monroe wrote an article in which he summed up quite neatly what it is that data centres do. Now, it would of course be very easy for me to just steal the words in his summary paragraph and use them to kick off this video. So that's what I'll do. He said this: data centres worldwide are energy transformation devices. They draw in raw electric power on one side, spin a few electrons around, spit out a bit of useful work, and then shed more than 98% of the electricity as not so useful low-grade heat energy. And that's because reusing that heat is not quite as straightforward as you might think. First of all, most data centres have historically used air to cool things down, and that tends to result in relatively low temperatures of around 28 to 35 degrees Celsius. And that heat is expensive to move around. Mark Monroe calculated the piping required to share heat with a facility a quarter of a mile away could add $250,000 to the cost of a data centre construction project. And data centres have often been located a long way from anything that can actually do something useful with their second-hand energy. But things are changing as we all move towards a greater level of environmental and energy efficiency consciousness. In Denmark, for example, Facebook has secured a tie-up between its facility in Odense and a local district heating company called Fjernvarme Fyn to recycle their waste heat. The warm air is directed over a coil filled with water. The air heats up the water, and the warm water is then piped across the street to a heat pump, which pushes the temperature up to more than 70 degrees Celsius before sending it into a district heating system. Heat pumps have coefficients of power, or COPs, as high as 6. In other words, for every unit of electrical energy you put in, you get 6 units of energy out. And that's because the fuel you're using is the free energy in fresh air. Monroe reckons a profit can be made from investing in one of these systems. He calculated back in 2016 that a 1.2 megawatt data centre selling all of its waste heat could make more than $350,000 a year, which could be as much as 14% of the annual gross rental income from the data centre. And much more importantly, of course, it had saved 6,000 metric tonnes of CO2 a year. In 2021, there were 7.2 million data centres in the world, so it's not hard to see how the potential CO2 emissions reduction from these heat recovery systems could become very significant indeed. The Facebook Odense scheme alone is expected to recover about 100,000 megawatt hours of energy per year, which is enough to heat almost 7,000 local homes. Switch data centres, who I mentioned at the start of the video, has opted for a slightly different heat recovery system called direct liquid cooling, or DLC. Rather than using air to cool the servers, DLC uses liquid-cooled heat sinks to transfer heat away from the components. The water reaches temperatures of 60 degrees Celsius, which is hot enough to be sent directly into nearby properties without the need for a heat pump. The heat gets used by the properties, which in this case includes a neighbouring hospital, and then the water can be recirculated back to the data centre without any additional cooling at all. Switch reckons that 97% of the server heat will be captured and delivered to 2,000 homes and offices, plus the hospital, and those customers will get a 20 to 30% discount on their power costs. The Netherlands actually has legislation called the Nearly Energy Neutral Building Rules, or BENG. That law suddenly makes residual heat from data centres look even more valuable to developers. It's a good example of how governments can gently nudge the commercial sector into doing the right thing sooner rather than later. Not many data centres have large, conveniently located district heating schemes right next door though, and of course heat energy is not always required by consumers at the point when it's generated by a producer. So a great deal of development work has been taking place to find effective ways to capture and store waste heat that can then be drawn down as required at a later time. And here's where we can add the industrial sector to our potential carbon footprint reduction. Total global industrial energy use was just short of 10,000 terawatt hours in 2018. According to this article from the European Commission, that equates to 37% of total global final energy use and 24% of global emissions. Between 20 and 50% of that energy is lost as hot exhaust gases or cooling water and heat losses from equipment and products. A research team from Eindhoven University of Technology has developed what they describe as a cheap, compact battery system for domestic use that could be a game changer for the energy transition. They all say that though, don't they? But in fairness, this one's based on the pretty well established thermochemical principle of adding water to salt to produce heat, and conversely using heat to evaporate water from salt, effectively storing heat energy inside the salt itself, ready to be liberated whenever required. The system is specifically aimed at utilising waste heat from factories and data centres using the tried and tested configuration of a heat exchanger, a fan, an evaporator condenser, plus a boiler containing salt particles. The team built a small proof of concept model capable of providing heating for an average family of 4 for 2 days, and they've now upgraded that to a fully working prototype, which I have to say is slightly alarmingly large, but I guess would fit in a basement or a large garage should you be fortunate enough to own such spaces. If you do though, then a setup this size would provide heat for your home for up to 2 months, enough to get you through the depths of winter. Here in the UK, a project led by Swansea University and the Active Building Centre Research Programme is being funded by the government's Department for Business, Energy and Industrial Strategy, or BEIS, through its Longer Duration Energy Storage Demonstration Programme, which itself is part of a £1 billion initiative called the Net Zero Innovation Portfolio, or NZIP. The project is called ADSORB, which of course is yet another catchy acronym. This one stands for Advanced Distributed Storage for Grid Benefit. They're looking at thermochemical storage systems, or TCS, similar to the salt storage developed in Eindhoven, and they're pursuing phase change materials, or PCMs. A PCM system would use waste heat to transition a solid material into its liquid form, effectively storing latent heat for several days. These sorts of systems have the potential to provide day-to-day storage of thermal energy at densities far greater than traditional technologies, releasing heat for hot water or space heating simply by pumping lower temperature water through the system. The majority of the global population already lives in urban areas and already accounts for about 70% of total primary energy usage. That's projected to hit 75% by 2030. We already know that renewable sources like wind and solar, coupled with energy storage systems, will most likely be the predominant form of energy provision for those towns and cities in the future. But if planners and architects can get the locations and logistics of new data centres and industrial facilities right, and find innovative ways to convert existing facilities so that they can recirculate their waste heat into city centres and suburbs, then they could provide some useful additional income to commercial operators and also play a crucial role in reducing our overall energy consumption and greenhouse gas emissions. Now, this sort of research has been going on for some years now, so no doubt there are plenty of you good folks out there who have some experience of these systems. If that's you, or if you've just got views on how these systems could be best integrated into our urban environments, then why not jump down to the comment section below and leave your thoughts there. That's it for this week though. Thanks as always to our amazing Patreon supporters who keep this channel 100% independent and completely ad-free. And I must just give a shout out to the folks who've joined recently with pledges of $10 or more a month. They are Colin Brooks, Archer Sully, Jack Liu, Michael Langford, Steve Hall, David Berman, Michael Cohen, Paul Nutsey, James Mackey and Alice Tullock. And of course a huge thank you to everyone else who's joined since last time too. If you feel like you could support the channel for the price of a coffee each month and keep me making these videos every Sunday, then you can find out how to do that by following the link in the description to www.patreon.com/justhavathink. And of course you can always show your support completely for free by clicking the subscribe button and hitting the notification bell so you never miss a video. It's just a simple click which you can do down there or on that icon there. As always, thanks very much for watching. Have a great week and remember to just have a think. See you next week.